out of the 6 problems the other day. Does everybody have their thing?
Yes.
Should I put it up on the board?
I know, it's so there.
Okay. So for this one, number 4, they give you a graph.
We reproduce it on the board.
I worked so
So they give you a graph. It goes from -4 to 0 to -2 to 6. And then here, and down to here, and there. So we have this piecewise linear function.
Oh, yeah.
It's so bad.
All right. So here's the graph of f, and they're telling us that g of x is equal to the integral from 0 to x of f of t dt. So the first thing you should definitely write is g prime of t, or of x, equals f of x. This is really g prime. Okay? That's the most important step of this problem, is recognizing that fact. Okay. So then it says, on what open intervals is g concave up? So what are you going to look for there? Yeah, you're going to look for f prime and where that's positive, right? Because f prime is g double prime. So you would just say, for A, you would say g double prime, right? G double prime equals f prime is positive on, and then you just give the intervals. So it would be like from -4 to -2, 4 to -2, in addition to 2 to 6. And that's it, right? Okay. Part B, it says, let P be the function defined by P of x equals G of x times f of x. And they want you to find P prime of 3. So this is a pretty standard problem where they define another function, and they're just testing you to see if you remember to use the product rule or the chain rule or the quotient rule or whatever it happens to be. This is the product rule. So it would be the first times the derivative of the second plus the second times the derivative of the first. And then you just plug in 3 for all these x's. So P prime of 3, G of 3 would be the integral from 0 to 3 of this function, which would be integrate from 0 to 3. It's going to be like this triangle area minus this triangle's area. So they just cancel each other out, right? So it ends up really just being like this little trapezoid right here. That's your figuring out its area, right? So it would be G of 3 would be 1/2 H times B1 plus B2, right? Or you could do it as, actually, it's easier to just count squares. It's 3.5. That's easier. So forget that. 3.5. Okay, so this ends up being 3.5. Yeah, that's negative 3.5 times f prime of x. So f prime of x would be the derivative at 3, which is positive 1, right? The derivative of this graph at 3 is positive 1, plus f of 3 which is just this graph's value, so it would be -3 times g prime of 3. And g prime is also f, right? So this would just be -3 as well. So that's the answer. Any questions on that? So far, this problem is really kind of easy, I think.
Yeah.
Yeah. Part C, just looking at it, I think it's probably L'Hopital's rule, but let's check it out. So it says find the limit as x goes to 2 of g of x over x squared minus 2x. So if you look at g of 2, that's the integral from 0 to 2. Yeah, it's definitely 0, right? Because you get this positive area and this negative area that cancel each other out. So this is a L'Hopital's rule problem for sure. So remember, what you have to do is you have to first show that you know the hypotheses of L'Hopital's rule, which are the limit as x goes to 2 of the top equals 0, and the limit as x goes to 2 of the bottom equals 0. So you have to state that. You have to state that since limit as x goes to 2 of g of x equals the limit as x goes to 2 of x squared minus 2x equals 0, you would say by L'Hopital's rule, the limit as x goes to 2 of g of x over x squared minus 2x equals the limit as x goes to 2 of g prime of x over 2x minus 2. Differentiate the top, differentiate the bottom. So g prime of x is just f of x, right? So if you substitute 2 into this function, you get -4. And if you substitute 2 into the bottom, you get 4 minus 2, which is 2. The answer is -2. That's it. That would be a full credit response. Okay. D, find the average rate of change of g on the interval from -4 to 2. So that would be g of 2 minus g of -4 over 2 minus -4. Right? So g of 2 is 0 again, right? Because it's the integral from 0 to 2. This is just 0. G of -4, that's the integral from 0 to -4. So it would be like these two triangles added up. Triangle. Do it that way. So this triangle is 1/2 base times height, which is 6. This triangle is 1/2 base times height, which is 2. And this is 8. So the total area is 16. But since you're going from right to left, it's negative, right? Is that what you were saying? Sorry, I interrupted. So this would be minus -18 over 6. Okay? And then it says, does the mean value theorem guarantee a value C between -4 and 2, for which G prime of C is equal to this average rate of change?
Wait, isn't it 16?
Oh, did I say 16? I wrote 18. Yeah, you're right. Thanks. So yes or no? Does the mean value theorem work for this function? I mean, what are they really asking you? Like, under what circumstances does the mean value theorem work? And differentiable. So that's the question. Is g of x continuous and differentiable? Yes, because this is the graph of g prime, and its derivative definitely exists everywhere. Even though this graph has corners, this is the graph of g prime. So that just the fact that this graph has corners just means that g double prime doesn't exist everywhere. But g prime definitely exists everywhere. So yes, since g of x, what I would say in this problem is, since g of x is differentiable, it must also therefore be continuous on this interval. And since it's differentiable and continuous, it has to, the mean value theorem has to apply. That's what they're looking for. Differentiable, continuous. That was a pretty easy problem, I thought. How many of you think you got at least 8 out of 9 points on that question? Nice. That's good. Number 5. So the first part, they're giving you an implicit function, 2y squared minus 6 minus or equals y sine x. This is a defined function, and it says find the derivative and just verify that it's that. Okay, that's easy. It's just implicit differentiation. So it would be 4y y prime equals y times cosine x plus sine x times y prime. Right, so then you group together the y primes, 4y y prime minus sine x y prime equals y cosine x, and then factor out a y prime and divide by the stuff that is in parentheses. So it ends up being 4y minus sine x. And that's exactly what they have here. So that would be, first part, that would probably only be worth 1 point, I would guess. Part B, it says write an equation for the tangent line to the curve at the point 0, radical 3. Okay, that's no big deal either. That means you need to find dy dx evaluated at the point 0, radical 3. So you just plug in 0 and radical 3 for x and y. So this ends up being radical 3 cosine 0 over 4 radical 3 minus sine 0. So cosine 0 is just 1, and sine 0 is 0. So you get 1/4. Okay, so far? So that's the slope we're going to use, and the point we're going to use is 0, radical 3. So it ends up being y minus the y value equals the slope times x minus the x value.
I'm pretty sure I left the slope as radical 3 over 4 radical 3. Is that okay?
Perfectly fine. Yep. C, it says for x between 0 and pi and y positive, find the coordinates of the point where the tangent line is horizontal. So what do you do here? Yeah, you set this equal to 0. So I would say, like, just to save time and copying stuff down, this is what I would write. I would say dy dx equals 0 when the top is 0. So y cosine x equals 0. And then just, that means either y equals 0 or cosine x equals 0. Okay? But if you look at the thing, it says y isn't 0. It says y is positive. So you can sort of rule that out. That can't happen. So cosine has to be somewhere between 0 and pi. Bless you. So cosine x equals 0 between 0 and pi at pi over 2. Right? Just picture the graph of cosine. It crosses at pi over 2 and 3 pi over 2. So that's that. Now they want you to find the coordinates. Oh, so this would not be full credit. We just wrote that. You have to now find the y coordinate of that same point. Right? So you have to plug into the original function, but the original expression. So 2y squared minus 6 equals y times the sine of pi over 2. Now you have to solve this for y. So it's a quadratic. Sine of pi over 2, what is that? It's 1. So you have 2y squared minus y minus 6 equals 0. Hopefully it's factorable. So how does this factor? Definitely factors.
It would be -4 and +3, right?
Or
It'd be 2y minus 4.
you're looking for numbers that multiply to be -6.
Yeah, but you have the 2 in front, so isn't that when you like split it into the grouping and then you factor out?
Okay.
I would have done
Yeah,
2y
oh, that's what Mr.
minus
Tucker said.
4y
Yeah.
plus 3y
Yeah, okay.
minus 6.
Yeah, so minus 4y plus 3y minus 6. This is the Kelly method. So this would be 2y times y minus 2
So basically,
plus 3 times y minus 2.
2 and negative, yeah.
So you get 2y plus 3 and y minus 2. Remember, the way I taught it in pre-calc, which you don't have to do it this way at all, but I just want to remind you just in case you like this way. Divide by 2, multiply by 2. So y squared minus y minus 12. Then you factor, it's 4y plus 3, and then you divide and multiply by 2 again. So you get the same result. Remember this?
Yeah.
You can do it this way. That way is perfectly fine. So you end up with y equals -3/2 or 2. So there's 2. Actually, y is positive, so it has to be 2. So the answer is x equals pi over 2, and y is 2. That's the final solution. That was a little confusing. Just the requirements of x and y, I thought made this problem a little weird, but
If you just got the x value and you didn't get the y value, how many points do you
I would guess that's probably a point if you gave the x value and no y value. A point off.
Yeah.
One point off, yeah.
Oh, okay.
All right. D, determine whether f has a relative min, a relative max, or neither at that point. You do that. What are they testing you on here? Everybody knows. What's that?
First derivative.
No. The first derivative test is when you make a chart, right, and you pick a point to the left and a point to the right. But if you have an implicit function like this, how do you do that? Like, how would you pick a point? A point on this curve, whatever it looks like, to the left and the right. It might be like vertical or something, you know. So I don't think the first derivative test works very well with implicit functions.
Oh, that's what I do.
How did you do it then? I'm
No,
curious.
that's what I did on the test.
Yeah.
First derivative.
So how though? I don't think it's possible is what I'm saying. So how did you do it?
Well,
So you have this point. What did you pick a point to the left of pi over
I did
2?
like 0 and 1. I'm pretty
But how do you know 0, 1 is on the curve?
sure. I don't remember what I did.
Yeah, do you see, but the issue though, like, how do you pick a point that's to the left of this point if it's not even a function and there might not even be a point to the left of it? It might be, you know what I mean? It might be like a random, like this curve might just look like this, right? And you're finding, and this happens to be this point right here. Like, how do you pick a point to the left of that? Like, I get you could pick an x value that's less than that, but then you'd have to find the corresponding y value that goes with that point and plug both the x and y value into dy dx to figure out its sign. Then you'd have to do the same thing, pick a point to the right, like, you know, like pi over 2 plus a little bit, find its corresponding, you know what I mean? It gets really confusing, don't you think? Plus, if I'm doing a first derivative chart on this function, it's going to be crazy because this is equal to 0 lots and lots and lots of places. My first derivative chart is going to be like infinitely many divisions, which is probably why they picked this function. So what's the alternative? Is there another way to find maximum other than the first derivative test? Second derivative test, exactly. So that's what you're going to do. You're going to take the second derivative and you're going to plug in this point, right? Remember the second derivative test says if the second derivative is positive, it has to be a minimum. And if the second derivative is negative, that means it's concave down and it has to be a maximum. This is the second derivative test that they're testing on. Does everybody understand that? Did anybody do the second derivative test on this?
I don't even remember.
Yeah, I have no idea. I don't think so.
Okay, so let's try it.
I don't remember.
They gave us the first derivative, so now we just need to find d y squared over dx, d squared y over dx squared, which would be the bottom, 4y minus sine x, times the derivative of the top, which is the first times the derivative of the second, plus the second times the derivative
I
of the
think I did this
first,
one, which I really don't know
minus the
how. I
top
think I did C one. I don't know how.
times the derivative of the bottom,
Because it's easy.
4y prime minus
Yes,
cosine
but
x,
some of those things I read during this class, like.
over the bottom squared.
And now plug it in.
Yeah, now you just have to plug in a point. Now, everywhere you see a y prime, we can just plug in 0 because that's how we got that point to begin with, it was 0, it's a point where the derivative is 0. So that means that this whole thing is 0, that thing is 0, right? You just have to plug in all the other stuff. So you end up with 8 minus sine pi over 2, which is 1, times 2 times negative 1 plus 0 minus 2 times 0, because cosine of pi over 2 is 0, times 0 minus 0. So it's not as bad as it looks once you start plugging stuff in. And then this is 8 minus 1 squared. So that whole thing is 0. All we care about is positive or negative. This is negative. The bottom's positive. Net result is this is negative. So is it a max or a min? It's a max by the second derivative test. Does everybody understand? I would say that part was probably worth at least 3 of the points in this problem. Okay? The last question looks like a Diffie-Q slope field problem. So they're giving us a differential equation, y dt equals 12 minus y over 3. So it says a portion of the slope field is given below. Sketch the solution curve through the point 0, 0. So you should have like something like an asymptote. Like your picture should have looked like where the tangent lines are horizontal right here. It should have been like something like that. Any questions on that? Then it says that's part A. In part B, it says using correct units, interpret the statement of the limit t goes to infinity of a of t. So what's a of t? It says a of t is the amount in milligrams of the medication in the patient at time t. So you could just say that after the medication is administered, the amount in the patient's bloodstream steadily increases to a certain level, and then it sort of flattens out. It plateaus at that level. It seems like the opposite of logic to me. It seems like it would go this way.
Yeah.
But that's what it seems like to me. It says at time t equals 0, there are 0 milligrams of medication. So. I don't know.
That's what
Yeah,
I
that's,
was,
when I was writing it out, I was
I was
like,
literally
right.
thinking that as I was doing this problem.
Yeah.
It's saying as time goes to
Yeah,
infinity,
this
so
would-
apparently this patient is always gonna have 12 milligrams or whatever in their system.
This would make sense if they said the initial amount in the patient is like 20,
Right.
then it sort of levels off at 12.
But
But I
still,
don't
it
really
always
understand.
has 12. I was thinking it would like level off at 0, it has 2 years of entry.
Yeah.
Yeah, I don't know.
Yeah.
The math and logic don't make sense.
Because the
Yeah, like I said-
person died with 12 in their
The mall opened at 5 a.m.
Does anybody have a different perspective? Because I don't think I'm getting this
Yeah,
right,
so
but
I said that
that seems.
you'll never have more than 12 milligrams in the system, or something like that.
Yeah. that's-
Oh, okay, I think that's right. I think we're right too. I think the deal is, it's like almost like an IV. It's like continuously being administered.
Oh, God.
And the most that it will ever, that makes sense now. The most that it's ever gonna administer is 12, like, so that your level is at 12 or a little under 12. I think that's maybe the situation. It's not like, here, take this pill. It's more like, here's medicine, here's more medicine, here's more. It's more like that situation. It's like, you're doomed to be on this medication until infinity. Okay, part C.
The mall opens at midnight.
They want you to solve the separable differential equation.
Yeah.
All right. How do you separate the variables here? What do you get? Separate those. What do you get? So remember, this is like 1 point. If you don't do this step though, you get 0 out of 5 in the rest of the problem. Like, this is probably a 5-point question here. And you get 0 out of 5 for not separating the variables correctly. You gotta make sure you do that part correctly. Then it's just integration. So this ends up, this is like the shortcut for U substitution. It's ln, absolute value of 12 minus y divided by -1. Right? Equals 1/3 t plus c. Are the absolute values necessary here or not? How do you know? Yeah, it's always positive, and if you just think about, if you substitute 0, 0 in, like 0 in for y, it doesn't matter whether the absolute value is there or not. So you can sort of ignore the absolute value in this problem. So what I would probably do, just to avoid sign errors from here on out, is I would find find c first, then solve for y. That's what I would do. But you have a choice, as always. You can either figure out what c is first, or you can solve for y first. I just don't want to make sign errors. So I'm going to solve for c first. So I get ln 12 over -1 equals c. C is ln 12. So this ends up being ln, forget about the absolute value, 12 minus y over -1 equals 1/3 t minus ln 12. Distribute the negative on the right, so you get ln 12 minus y equals -1/3 t plus ln 12. E both sides, so you get 12 minus y equals e to the -1/3 t plus ln 12, which if you wanted to, you could use some like laws of logarithms to simplify this. Like if you did that, this would end up being 12 times e to the -1/3 t. Does everybody see how that is? So if you're going to do that, which you don't have to do it, but if you're going to do that, make sure you do it properly. Bless you. So then subtract 12. So you get 12 minus, or 12 times e to the -1/3 t minus 12, and then just negate that side. So you get -12e to the -1/3 t plus 12. You have to solve for y. If you don't solve for y, you don't get full credit either, because it says find y equals a of t. So you have to solve for y. That's a point in the process. So remember, this would be like a 5-point question. You get 1 point for separating the variables, 1 point for each antiderivative. So that's 3. 1 point for finding the correct value of c, and 1 point for solving for y. Raise your hand if you think you did that correctly. Probably. I know you probably don't remember, but.
I think I did.
So that's it.
No,
Oh, there's a D?
I remember being so confused by that.
Oh, there's a D.
Because I read it, I was like, why are there so many words? Here's this.
All right, so it's unusual. This is a lot of work for one of these types of problems. It says a different procedure is used to administer the medication to a second patient. The amount in milligrams of the medication in the second patient at time t equals, at time t hours is modeled by the function. Okay, so if I'm comparing these two functions, they're not really. Okay, I thought maybe one of them might have been like a vertical or horizontal shift of the other one, but it's not. At time, so if I'm reading this question, that's my thought process. At time t equals 1 hour, there are 2.5 milligrams of the medication in the second patient. Is the rate of change of the amount of medication in the second patient increasing or decreasing at time t equals 1? What do you do?
Right, if it's the.
I didn't hear what you said the first one.
Sorry, I took like, if they give you, what would it be, B prime?
Yeah.
And I found B double prime.
Yeah,
Okay.
I agree. Yeah, because if this is, whoops, y over t plus 2. If this is the rate at which b of t is changing, then if you want to know if that rate is increasing or decreasing, you'd want to find the derivative of that, right? So you'd find d squared y over dt squared, which is, I mean, the 3 just goes away. So it's negative. I'm gonna pretend like this negative is attached to the y, just to make it easier for me to deal with signs. So it's the bottom times the derivative of the top, which is negative y prime, minus the top, negative y, and the derivative of the bottom, which is just 1, over the bottom squared. So the point that they're giving us is the point 1, 2.5. So if you substitute those values in, you get 3 times, if you put 2.5, or let's see. So dy dt at the point 1, 2.5 is 3 minus 2.5 over 3, right? So 2.5 divided by 3 is like 5/6. Okay, 9 minus 2.5 over 3. So this would be 6.5 thirds. Is that what you said to do?
If you multiply both by 3.
Or did you multiply both by 3? Just multiply this by 3.
Okay, yeah, that's it.
Right? Did I make a mistake? Seems right to me. Still don't know what that is, but who cares? Oh yeah. 6.5 thirds plus y over 3 squared. So this is definitely positive. This is negative. It's definitely negative. So the answer is the rate at which b of t is changing is decreasing at that moment because b squared y over dt squared is negative, and you have to give a reason.
That's cool.
So Number 6, I don't think there was any hard parts about it, but it was long. It was like a lot of work, kind of. Like, I could see that taking longer than 15 minutes for that question. But like number 4, I could see that taking less than 15 minutes because I thought that was pretty easy. And actually, number 5 was kind of easy as well. So, it's with the exception of the second derivative test. You gotta remember that. All right. Any questions? So raise your hand at what score you think you got.
I'm gonna confidently say.
I'm hoping.
All right.
I don't know.
I don't know.
Which one
So we're
is
playing
mine?
games tomorrow?
Yeah. Yeah, we'll play games for the rest of the year now.
We play terraforming Mars tomorrow?
It's not really like a 10-person game.
Yes, literally.
What is this?
Sorry.
What is it?
Terraforming Mars.
I was like, oh.
Yeah.